This is the warm-up for Lesson 22, Arithmetic Sequences. So take a second and do this. Hit pause. Alright, so we want the first 5 terms of this sequence, so we're just going to say that if I wanted the first term, I'd substitute in a 1 for n, so that's 1 plus 3. The first term is 5 over 4. The second term, I'm going to substitute in a 2 because I want the second term. So this is 2 plus 3. 5 over 5, that can say that's 1. Our third term, 5 over 3 plus 3, 5 6. Our fourth term, 5 over 4 plus 3, or 5 sevenths. And our fifth term, 5 over 5 plus 3, 5 eighths. Today is Lesson 22, Arithmetic Sequences. In an arithmetic sequence, the difference between consecutive terms is constant, and this constant difference is called the common difference, denoted by the letter D. The nth term of an arithmetic sequence with first term, we read that as a sub 1. You could also see it as a of 1. And common difference D is given by a sub n equals a sub 1 plus the quantity n minus 1 times D. The expression formed by adding the terms of an arithmetic sequence is called an arithmetic series, and we'll get to that later on in the year. So what they're saying here is that if we had a sequence, let's say we had the numbers 3, 6, 9, and 12, and that meant it went on and on forever with those dots. That's an infinite sequence. Then describing some terms here, a sub 1, the first term, is 3. The D, the common difference, is how far, what am I doing to go from one term to the next? I'm going up 3. Going up 3. So my common difference here is also 3. Our first example, decide whether each sequence is arithmetic. So in order to be arithmetic, we're going to add or subtract by the same number each time. So from 2 to get to 11, I add 9. 11 to 20, I add 9. 20 to 29, I add 9. 29 to 38, I add 9. So yes, this is arithmetic. A for arithmetic. Here we're adding 2, then we're adding 3, then we're adding 4. That's a different number each time. So this is no, it's not arithmetic. Some people also pronounce this arithmetic. I go back and forth. Usually I say arithmetic. Decide, here's your guys' try. You guys do this one. Tell me if this is arithmetic, so take a second and do it. We can see from 12 to get to 7, we subtract 5. 7 to 2, subtract 5. 2 to negative 3, subtract 5. 3 to negative 8, subtract 5. So yes, this is arithmetic. On our next one, 4 to get to 8, we add 4. 8 to get to 16, we added 8. 16 to get to 22, we added 6. That's not the same, so no, this isn't arithmetic. Writing a rule for the term. So we're given a sequence. So we've got 1, 2, 3, 4, 5 terms here. So to make our rule, we need to know what our first term is. Our first term here is a 2. The second part of our rule is finding what our common difference is. So from 2 to 11, we add 9, and we're added 9. And you only need to do that a couple times, but I'm just showing it to you. So our common difference is 9. Then we use the general form of our rule. That's a sub n equals our first term plus n minus 1 times our common difference. You'll also see it, you know, a of n in function notation equals a of 1. And you can see this d on our left side too, of n minus 1. So it doesn't matter which side your d is on, and it doesn't matter if we're using function notation or subset notation. It makes no difference. So all we're going to do now is just plug it in. So I'd say our first term is 2 plus n minus 1 times 9. Now we can simplify this. Technically this is correct. You might see that as an answer, but you might also need to do a little bit more math, and doing a little bit more math would mean to distribute. So I'd say 2 plus 9n, and then multiply here, and 9 times negative 1 makes negative 9. This also makes it easier to find our 15th term later. So 2 minus 9 is what? Negative 7. So our rule is a sub n is equals 9n minus 7. So what are we going to do? We're going to use this rule. Use this rule, a sub n equals 9n minus 7. So if I wanted to find the 15th term, that's what a sub 15 means. So a sub 15 would mean to just plug in a 15 for n. So what's 9 times 15? Well, 10 times 15 is 150, so 9 times 15 would be 150 minus 15, so that's 135. And 135 minus 7 is 128. So our 15th term is 128. So you guys try this. Write a rule and then find the 15th term. We can do 2 of them here. Take a second, hit pause and do it. We can see we're going down by 5. Down by 5. So our common difference is negative 5. Our first term is 12. We're going to be plugging those in to our general form. And now we're just plugging in terms. First term is a 12 plus n minus 1 times negative 5. I put that negative 5 in parentheses because if I didn't, then that would just be subtracting 5. Now we simplify and we get 12 minus, because negative 5 times n makes negative 5n. Negative 5 times negative 1 makes positive 5. And now we can combine some like terms. And 12 and 5 combine to make 17. So it's negative 5n plus 17. That's our general rule. Now to find, what's it ask for? It asks for our 15th term again. Ooh, we're going to need to do a little math. So this is our answer, or that's our general rule. And now our 15th term would be a sub 15 equals negative 5 times 15 plus 17. So what do we need to do? Negative 5 and 15 makes negative 75 plus 17. If you remember, we have a negative and a positive, so we're going to say we know our answer is going to be negative. Sign of the bigger sign, and then we take the bigger number, 75, and we subtract the smaller number, 17. and so that's 8. 6 minus 1 is 5, so that's negative 58. For our other one, 19 to 23, adding 4. 23 to 27, adding 4. So our common difference here is 4. Our first term is 19. First term. We use our equation. A sub n equals a sub 1 plus the quantity n minus 1 times d. Then from here, what is my first term? 19 plus n minus 1 times 4. I don't put this 4 in parentheses because it's positive. We multiply, we get 19 plus 4n minus 4. We can combine our like terms. So our rule is a of n equals 4n plus 15. That's our rule. Now we would like to find the 15th term again. So I'm going to say a of 15 equals 4 times 15 plus 15. 4 times 15 is 60, and 60 plus 15 is 75. So our 15th term in the sequence is 75. I apologize for my computer's not wanting to pick up my pen very well. I know my handwriting's nasty, but it's not that nasty. So here are some similar types of problems that you'd see on your homework. Find the first 5 terms of the sequence. A sub 1 or a of 1 equals 2. That just means our first term is 2. And then our common difference is 5, so what's 2 plus 5? 7. 7 plus 5, 12. 12 plus 5, 17. And what do we want? 5, so one more, and 22. Another one, write a rule for the nth term of the sequence. So we're going to use our equation again. So this is our first term plus n minus 1 times d. So we're going to say our first term is 7 plus n minus 1 times negative 3. We'll multiply in here. 7 plus negative 3 and n. Oh, that makes a negative 3n. And negative 3 and negative 1 makes positive 3. 7 and 3 combine to make 10. So negative 3n plus 10 would be our general rule. Today's homework is homework 22.